Hi everyone, the next topic is resampling method. In the last video, we studied sample function, which sample observations from fixed dataset. Suppose that we have set of 1, 2, 3, 4 that we sample from this dataset randomly. If we think about sampling with replacement, we have, for example, this kind of sample. So we originally have 4 observations, and we sample, for example, the 6 observations from this sample. For each choice is random, so randomly pick up observations from 1 to 4 with probability 1/4 each. And we use this method to evaluate the variability of the data. So the idea is that, okay, so suppose that we have original data such as 1, 2, 3, 4. And to evaluate the variability of the data, that we resample from this data set with the same number of observations with replacement. So for example, 1, 4, 1, 3, or 2, 2, 3, 1, or 1, 1, 4, 4. So if we think about many samples by this resampling method with the same number of observations, that we can evaluate, for example, the sample mean of the original observation is 2.5, but we can evaluate another sample mean by taking average of these 4 observations. So in this case, the total is 9, so this is 2.25, and this average is 2.0, and this average is 2.5. So in this way, we have some variability in this simulated X bars. So now that we can see how reliable this X bar is. X bar is equal to 2.5, but we have some variability if the same kind of observations appear in a new sample. Okay, so now that we work on an example, so we have data with 5 observations, 5.1, 4.8, 3.9, 5.3, 4.1. And we want to calculate the sample mean and the sample standard deviation of the data. Then we estimate the standard error of the sample mean theoretically. So actually, we have X bar is equal to 4.64, and the standard deviation sigma hat is equal to 0.61, but with these 5 observations, we can only see 1 X bar. So we don't know how reliable this number is, but if we use this resampling method, we can evaluate the standard error. But actually, we can give theoretical the standard error of X bar first. Then after that, we use this resampling method to get the standard error of X bar by simulation. Okay, so at first, the theoretical solution here. So we have 5 observations in the previous example. So suppose that we have x1 to x5, and suppose that xi follows some distribution with mean mu and variance sigma square. Then we are thinking about X bar. So X bar is equal to average. So 1/5 times X1 plus X2 plus up to X5. And we want to calculate the standard deviation of X bar. So to get that, we have to get the variance of X bar. So variance of X bar is variance of 1/5 times summation of Xi. But variance is squared quantity, so this becomes 1/5 squared times variance of x1 plus up to x5. And variance is linear function if x1 to x5 are independent. Okay, so if independent, so this becomes just 5 times sigma square because variance of xi is equal to sigma square. So this becomes 1/5 sigma square. So finally, the standard error, that is standard deviation of x bar, is equal to sigma over square root of 5. So that's why we get this formula. So here, standard error and the standard deviation have the same meaning, but the standard error, the term standard error, is used for some estimate. X bar is an estimate for this mu, so that's why we say standard error. Okay, so this method is perfect because this is theoretically correct, but this is possible because the problem is easy. If we have more complicated statistical model, then we estimate some parameter such as beta, and beta hat is complicated quantity, then it's not easy to get standard error in this way. So it's beneficial to use resampling method. Okay, so this is the sample R code for sample mean, sample standard deviation, and the standard error of x bar theoretically and also by simulation. Okay, so x bar is here, and sigma hat is here, and theoretically, standard deviation of x, that is sigma hat, estimated standard deviation of x is sigma hat, and divided by square root of 5, that is the estimated standard error of x bar. So this is 0.274. And if we use simulation, then we can do this way. So at first, we prepare a vector m to store 100 different x bars. So for the first resample, we calculate x bar, then we say that as x bar superscript 1. And we calculate this 100 times for different samples. Then after that, we can calculate standard deviation of these 100 observations. So that can be done by this code. I is equal to 1 to 100. At first, we sample from x. X is the data, and with replacement. So we take 5 observations from x with replacement. Then take sample mean. So we now get x bar to superscript I from I is equal to 1 to 100. Then finally, we calculate standard deviation of these 100 numbers to get this. So this is the estimated standard deviation of x bar. Okay. So these two numbers are different because of 2 reasons. So first reason, the simulation is actually random. So we have some intrinsic error. And the second reason is that actually this formula is not theoretically perfect. Actually, we have difference between sample variance and the population variance. Actually, we assume that the population in simulation, the population variance of this x is the true variance of this simulation. But usually, the sample variance of x is unbiased estimate for the variance of x. So we have some small discrepancy. So actually, this tends to be slightly smaller than this one, but at least it's close. And if the number of observations are larger, the difference is negligible. So this is the how we run resampling in our language.